Okay, let us start our today topic. We already discussed about the functional dependencies. See how to find functional dependency, how to find the relationship between the attributes, how an attribute depending on another attribute, how to find it by using this formula. If t1 dot x equal to t2 dot x, then t1 dot y equal to t2 dot y. That means what? X determines y, right? How to understand this? See, we have one table. If you understand this concept, then only we can understand the closure activity, super key, and candidate key. If you understand those concepts, we can understand the normalization concept. Okay. See, this is X attribute. And this is Y attribute. See here, I have X value and Y value D. You see Y value D. Then A, then B. This is relation R. Okay, the relation R, we have the attributes X and Y. We have the attributes X and Y. Now, to find functional dependency between the attributes, how to check? We have the formula already. We have the formula. See here. If t1 dot x and t2 dot x, then t1 dot y equal to t2 dot y, then we can say A tends to B. That means X tends to Y. Can apply here. See ma, here T means what? Tuple means row. Here T1 row, this is T1 row, T2 row and T3 row. See, if T1 dot x means in the first tuple the attribute x value is A, then T2 dot x, next to T2 dot x means T2 tuple, then value is C. So condition is returns true or false. Tell me all of you. False, right? If it is false, you no need to go inside of this. Okay. Next T1 is, this is the T1 tuple. X attribute is A. That means A equal to T2 dot x. T2, this one now it is T2. T2 dot x. T2 dot x means A is equal. Then it returns true value. It returns true value here. It returns true value. Then t1 dot y, t1 dot y attribute, t1 dot y attribute value is what? B equal to t2 dot y, t2 coming to this t2 dot y, t2 dot y value is what? B. Now it is equal. That means now in this case I can say x stands to y. That means x determines y, then y depends on x. This value depends on this value. Okay. So if you satisfy this formula, that means we have functional dependency. We have functional dependency. I think you understand like with this one, right? t1 dot x means what? In the t1 row, first row, x value equal to t2 dot x means second row x value is equal or not? Yes, these two are equal. Then we can check here. Next, t1 dot y and t2 dot y. T1 dot y and t2 dot y both are equal. That means this is also true. That means we can say x determines y. Okay. Coming to in this case, so t1 dot x and t2 dot x false. Then if it is false means you no need to go inside, right? You know if condition, right? In Java, same thing here. Here also you can apply. So only in this case it is true. Now I can say x determines y. In this way we can find the functional dependencies between the attributes. Functional dependencies between the attributes. X stands to y. That means y depends upon x attribute. That's about functional dependency. Next, you need to understand. After that, you need to understand the rules. So we have nearly 6 rules. So the primary axioms are reflexivity rule, augmentation rule, transitivity rule. So reflexivity rule means A is a set of attributes and B is a subset of A. Then A holds B. That means A turns to B. Okay. If it is augmentation, if A holds B and C is a set of attributes, then AC holds BC. We can write like this. Means AC holds BC. It means that attribute in depends does not change the basic dependencies. Next, transitivity rule. Here A turns to B and B turns to C. Can I write A turns to C? Yes, I can write. That is the transitivity rule. A turns to B means B turns to C means I can write A stands to C. That A determines C. Okay, this is transitivity rule. Union rule means C determines B and A determines C. I can write A determines BC. A determines BC. If you write like this means what? Union rule. Decomposition. If A stands to BC, next to A stands to B. That means A determines B. Then we can write A determines C. Okay. See, this is decomposition rule. Pseudo transitivity rule. A stands to B. That means A determines B. BC determines D. Then I can write AC determines D. So based on this, we can find the dependencies, functional dependencies. Okay, how we can find the functional dependencies based on these formulas. Okay, based on these rules. So here, what I need to do here means, so I need to find the closure activity. Okay, after finding the functional dependencies, I need to find the closure activities. Based on that, we can find the super keys and candidate keys. See here, attribute closure of an attribute is a set, can be defined as a set of attributes which can be functionally determined from it. Okay, attribute closure means say set of attributes. So it contains set of attributes of relation determined by of it. So how it will be, we will see. So first to see the note, to find the attributes closure of attribute set, add elements of attribute set the result set. Okay, recursively add elements to the result set which can be functionally determined from the elements of result set. If you go through the examples, then you can understand. So this is the algorithm. see here. So attribute closure. So how to find attribute closure based on this algorithm? See how to find closure. See, a plus symbol represents closure. This plus symbol represents closure. Closure. X closure. X closure means X contains set of attributes of relation determined by X. So it contains set of this closure. X plus is a closure here, right? This closure contains set of attributes X comma Y comma, not only X comma X Y Z. It's a set of attributes. So set of attributes of a relation, so that determines X value. Okay. So see the algorithm. First, determining X, the closure of X found F. So input is, let F be the set of functional dependencies. So relation R. Okay. We have a relation R. We need to find the functional dependencies. So then we can find the closure activity. See, three steps we need to remember here. So X closure. That means we are initializing the X value. X closure means, so X attribute. Okay, for each FD, for each functional dependencies, for loop, like this is a for loop. So in the for loop, what we are checking, Y determines Z in FD. Y determines Z. That means Z is depending upon the Y or not. We'll check here. If it is true, then if condition. If condition is what? Y subset closure X. So then X closure equal to X closure union Z. We can write like this. Okay. If for loop Y determines Z, then Y subset X closure, then X closure equal to X closure union Z. We are combining here. We are performing union operation. X closure union Z. Z is attribute, right? So that means what? If Y is contains X value, X closure, Y is contains X closure, then Y is contains X closure, Y is contain X closure. Add Z to X. We are adding Z to X. We are adding Z to X. So this is the if condition. If Y set of X closure, then we can do like this. Then for loop repeats like this. You can find the number of X closures. Then return X closure value. We can return the X closure value. So output is what? Closure of X under F. See, you can find the some X closure. Let us see one example here. See, this is X. Then what is the symbol of closure? Plus is a symbol of closure. Then what is the meaning of this? What is the meaning of this? So it contains set of attributes. What is the meaning of this? X closure contains set of attributes of relation R, something of relation R. So determined by X. So this is the closure symbol. So that contains set of attributes of relation R determined by X. This is the definition of attribute closure. Okay, we have the relation here. We have the relation. See, we have the relation R. We have the relation R. But R relation having comma B comma C comma D comma E. These are the attributes. So let us find the functional dependencies, and let us find the attribute closures here. By using this example, we can find it. See here we have the relation. The attribute names are what? A, B, C, D, E. Then what is the functional dependency here? So this is the given functional dependency. So in the question they will give like this. We need to find later the attribute closure and functional dependency super key and candidate key. Okay. Now this is the given functional dependency. Like A stands to A stands to B. Okay. Next to B stands to C. Stands to C. Then C stands to D. Then D stands to E. So this is the given condition, given relation and functional dependencies. Based on this, we need to find the attribute closures. Sima here, based on rules, we need to find the some functional dependencies. See here, A determines B. Okay, here A determines B, B determines C. That means, can I write A determines C? Can I write or not? Transitivity rule. This is what? Based on transitivity rule. Transitivity rule. Okay. If A tends to B, then B determines C. Then we can determine A tends to C. A determines C. Okay. I can write like this. So not only they are given some functional dependencies, right? So we can have indirect functional dependence by using rules. By using those rules, we can find indirect functional dependencies like this. Okay, I can write A tends to C, means A determines C. If A determines B, B determines C. Based on transitivity rule, I can write A determines C. Okay. Next, can I write A determines A? Can I write A determines A? Yes, I can write. This is called reflexivity rule. Reflexivity rule. Okay, reflexivity rule. I can write like this. Okay. Can I write? See here, A tends to B. Next to B tends to C. C tends to D. C determines D. Can I write A determines D? We have relation, right? A to B, B to C, and C to D. Now I can write A to D. Okay, that is called transitivity rule, right? A determines D value. A determines D. Okay. Next to A determines B, B determines C, C determines D. Then D determines E, right? Can I write A determines E? Right. Yes, we can write. Next, I can write A determines E. Okay. This is transitive rule. Next, can I write like this? A determines A, B, C, D, E. Can I write like this? Yes, I can write. This is what? Union rule. This is union rule. Okay, I can write like this. So in this way, I can find the dependencies. Okay, not only this. B. B tends to C, C tends to D. In the given functional dependencies, we have B determines C, then C determines D. Can I write B determines D? Yes, I can write. That is transitivity rule, right? Yes, I can write. In that way, I can write B tends to E also. Next, can I write B determines B? Yes, I can write. B determines B. I can write like this. Next, tell me union rule. Can I write C? This is union rule. So because B determines C, C determines D, D determines E. I can write like this. Okay, D determines E. I have D. Can D determines E? Yes, I can. Okay. Next, and B can be determines A. Can B determines A? Is it possible? No, it is not possible. It is not possible. Okay, this is not possible. So B is cannot determine A. From this relation, B is cannot determine A. Okay. Okay. Think you understand this. So then tell me of C. 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 C determines D. D determines E. Okay. So I can write like this. Then I can write C determines E. Okay. Next, C determines C itself. So that is a reflexivity property. Reflexivity property. I can write C determines C. Then tell me the union property. So can I write C? C determines what? D. So I have C. C determines D. Then D determines E. So I can write like this. C. Next E. I can write like this. Okay. Coming to E. So E. Here, do you have any relation attribute? E determines anything here in this relation? No, right? So then, according to reflexivity rule, I can write E determines E. Okay, doesn't have any other functional dependencies between the attributes. Okay, in this way we can find indirect functional dependencies. In that way we can find indirect functional dependencies. I think you understand, right? The functional dependencies. How can you find the functional dependencies? Now our topic is what? Finding the attribute closure. Attribute closure. So how to find it? How to find it? See here. I have the relation, this one. Where is the relation? Okay, it is again. I have the relation contains attributes A comma B comma C comma D comma E. Okay. From this relation, they have given some functional dependencies. Functional dependencies. So you have the functional dependencies. So same thing. A tends to B, B tends to A. Sorry, B tends to C. then C tends to D, tends to E. Based on these functional dependencies, we can find, we should find the attribute closure. Attribute closure. See how to find it. How to find this. First, find the A closure. A closure. This is the symbol for closure, right? Power. So this should be in power. A plus. Plus is the power of A. So here A closure. A closure. Can I write like this? A closure. So here A determines B. I can write A value. Okay, A I can write. Next, A determines B. B determines C. So A determines B, right? So I can write B value. Then B determines C. I can write C value. Then C determines D. I can write D value. Then D determines E. Then I can write E value. E attribute I can write here. So this is the attribute closure. Okay. So in that way, can I write attribute closure for AD plus. Attribute closure means not only one attribute. I can use multiple attributes as a key. Multiple attributes as a key. AD is a key here. AD is here. So multiple I can write in the closure. So so A D. So A D. So here in shortcut way we can say AD determines itself. So based on reflexivity property, reflexivity rule, I can write AD determines itself. A comma D I can write. Okay. Next, after that, B determines C, then C determines D. That means D determines B. I can write B also here. B determines C. Next C determines D. D already there. So we no need to write again. Then D determines E. So B determines C, right? First I need to write C value. Then C determines D. Already D there. Then D determines E. Then I can write E value. So this is AD closure. Next again you can check A determines B, B determines C, C determines D, D determines E. Everything is covered. Okay. Can I write B closure? B closure. Find the B closure here for B attribute. So closure. So in above functional dependency, A determines B. Okay, we cannot back. So we can start from B determines C. So B determines itself. Okay. So according to reflexivity rule, I can write D. I can write B here. Next, B turns to C. Means B determines C. I can write C also. Okay. Next C determines D. Then that means what? I can write D attribute also. Then D determines E. Then I can write E also. Then E determines nothing. Okay. Coming to A, next again repeat. A determines B. So but B determines C, not A. So we can stop here. Okay. So this is another closure. Next, can I write CD closure? CD closure. CD is one attribute here. Okay. CD closure. So find the closure attributes. CD closure attributes. So CD determines itself based on the reflexivity. According to reflexivity rule, we can write C comma D, because CD itself determines itself. CD determines itself. Okay, CD I have written. So here C determines D, already D there. Next D determines E. D determines E. So I can write here D determines here I can write comma E. Write like this. Okay. So how can I write like this? CD closer CD comma D. So it determines itself. So I can write CD like this. Then C determines D. So already D there. Then D determines E. So D determines E. I can write CD closer. Okay. Are you understanding how to find the closure activities based on that algorithm? So tell me how to find AB closure. Yes, all of you. Someone please reply me how to find AB closure. AB closure. Yes, all of you. Can anybody reply to me? E8, E8, E8.
Yes, sir.
Can you tell me AB closure attributes? AB closure. Based on this dependency, tell me how to write AB closure. Are you understanding or not? See here, AB closure. That means what here? According to reflexivity rule, I can write A comma B. Okay, A comma B. AB values, AB attributes I can write. Then search in dependency, given functional dependency. C A turns to B, B turns to C. So B turns to C. So B turns to C means, so B have the relation with C, right? So I can write C value also. I can find the C value also. Next, C determines D. That means what? I can get the D value also. That means I can write D also here. Next, in the given dependency, D determines E. That means I can write E also. Okay. In this way, I can find the closure activities. Closure activities. Are you understanding? Okay. Let us see the super key and candidate key. See super key. What is super key? What is super key? Super key is a set of attributes of relation which can be used to identify the tuples uniquely. So we have a one relation, one table. In that, so super key set of attributes. We have set of attributes. So based on that attribute, we can find that row uniquely. So based on that attribute, by using that unique attribute, we can find the values. Okay, by using that super key attribute. So that super key attribute no need to be one attribute. It contains many attributes, one or more. Okay, that means set of attributes in the relation which can use to What is the purpose you are using super key? We are identifying the rows uniquely. Okay, uniquely we can identify. So adding 0 or more attributes to candidate key generate super key. So if you add 0 or more attributes to the candidate key, we can generate super key. A candidate key is a super key, but vice versa, not possible. So candidate key is a super key, but super key is not a candidate key. So candidate key is a super key, but super key cannot be a candidate key. Okay, so this is the rule for super key, right? Then what is candidate key? See, candidate key is a minimal set of attributes of a relation which can be used to identify the tuple uniquely. Same like super key, but it is, the difference is what? Minimal set of super key. Minimal set of attributes in super key. Okay, super key is a what is super key? It is a set of attributes of relation which can be used to identify the tuples uniquely. Same thing. But candidate key is a minimal set of attributes. Minimal set of attributes. That means minimal to super key. Okay, that is the difference. So consider one table. So student is a table. Student having student number, student name, student phone number, and age. We can take student number as candidate key. Okay, we can have more than one candidate key in a table. Okay, types of candidate key, we have two types. First one is simple, that means we have only one attribute. Okay, that is candidate key. Here SNO, student number, is candidate key, that is only one attribute. We have composite attributes. Composite means multiple attributes as a candidate key. Multiple attributes means student number and student phone number. That we can say, okay, we have examples here. See, what is contains employee, employee ID, employee name, number, and employee values, name having duplicate values. Okay. That means in this organization, so from this department, okay, from CSC department, we have two employees with the same employees with the same name, Neha. So, uh, two, and is not these are in the department name. We have the employees. Okay, next Aadhaar number. So this Neha Aadhaar number is different, or this Neha Aadhaar number is different, and the email ID and email ID also different. Here they are from same department. Same department. Department having department ID 1, 2, and 3. See, these Nehas or both are from same department. So now find the super key. Find the super keys. So because of one super key, because of that, we find the uniqueness in the row. So which type of attribute is this? Employee ID. Based on employee ID, we can find the unique values. Okay, we can find the unique values. Okay, if I want to uh, by using employee Neha, I can derive because this is employee ID is unique. So that's also super key. So Aadhaar number. So this is also one. That is also okay. Email ID. That is okay. We can find the super ID unique. Other number values, right? So email ID means so three values are values. Now what is the combination of attributes? So any attributes, nothing classes. Employee ID, and say these two are super key. This is also super key. So based on ID number, can I find the name of the employee? Yes, I can find the name of the employee. First, let the employee, the department number of department ID of the. Can write in this combination also. In this combination also, I can write super key. So Aadhaar number, email ID. So Aadhaar, email ID. I can combine both. I can find the name of the employee or department ID of the employee. You can write the many combination. Many combination. These all called as super keys. So these are super keys. Employee ID name. Based on employee ID name, I can find the other values. So this represents the uniqueness from the row. Based on unique value, we can find the remaining values, right? We can search the values easily based on the unique value. So combination of these two, we can find other value. So this is called super key. This is called super key. In this way, we can write the combinations. So if you combine these attributes, if you are able to find the unique value, then that is super key. Okay, I think you understand here. These all are super keys. All are super keys. Next, candidate key. What is candidate key here? Candidate key. Candidate key is super key. Candidate also can be super key. So here employee ID is a super key. Other number is a super key. Employee is, email ID is a super key. So these all are super keys, right? Why candidate key? So super key also be a candidate key, but candidate key cannot be a super key. So how to find the candidate key? See here where unique values minimal number attributes, minimal attribute, minimal of super key. Minimal of super key means these are a combination of attributes, right? Minimal attributes. So how to find minimal attributes from this combination of attribute? Find the candidate key. So employee ID is candidate key already there. Okay, already it is a super key. So Aadhaar number, from this I can find Aadhaar number. Next email ID, email ID. So Aadhaar number, email ID, employee email ID, Aadhaar number, employee ID. So from this employee ID, so from all these combinations I can find the candidate key here, and in this what is employee ID is a candidate key. From this what is the candidate key? Employee ID is a candidate. And how I can say minimal super key is what? Candidate key, right? These three are minimal super keys. That means those are candidate keys. So employee ID, Aadhaar number, email. Minimal. Okay. So these are candidate keys. Think you understand, right? See the rules, then only you can understand. Just read all the rules. Okay.